Please start writing. Okay, so the next topic is homogeneous equilibrium. So, what is homogeneous equilibrium? From the name itself, we can understand homogeneous, all should be in the same phase. A process or a reaction which is reversible and has achieved equilibrium, containing all species in the same phase, is an example of homogeneous equilibrium. All species should be present in the same phase. So it's a single phase. Examples, if we look at then, in the first example, if you see, every species is liquid. That means all the species are in the same phase. Since all the species are in the same phase.
Could you scroll up yet?
Yes, yes. So all the species are in the same phase. It's a single phase for the entire reaction. Then we say that it is an example of homogeneous equilibrium. So if an equilibrium is existing for a reaction wherein all the participating species are in the same phase, we call that an example of homogeneous equilibrium. So homogeneous means all should be in the same phase. These are the examples. In the first reaction, all the participating species are in liquid phase. In the second reaction, all the participating species are in the gaseous phase. So this is an example of homogeneous equilibrium. So then the opposite or the other type should be heterogeneous equilibrium. So when two or more phases are present in the same reaction or process, the equilibrium established will be heterogeneous equilibrium. At least two phases should be present. So when two or more different phases are present in the same reaction, then the equilibrium established is called heterogeneous equilibrium. Examples, we have already come across the first example many times.
सर आप एक बार homogeneous के example सिखा सकते हैं?
Of homogeneous.
सर फर्स्ट रिएक्शन कैसे हो सकता है? सर आई थिंक प्रोडक्ट रॉन्ग है.
Okay. Yeah. Okay, correct. These are the two reactants in the first reaction: CH3COH and C2H5OH. So the acid reacts with the alcohol to form an ester and water. All
हो
the
गया सर.
phases are, all the participating species are in the same phase. So liquid phase is the single phase in the first reaction. In the second reaction, gaseous phase is the single phase. So for heterogeneous, we have two, that is at least two phases or more than two phases in the same reaction. These are the examples of heterogeneous equilibrium. Calcium carbonate is a solid, calcium oxide is a solid, carbon dioxide is a gas. So we have two phases here, solid and gas. In the second one also we have two phases, solid and gas.
सर 1 मिनट लास्ट एग्जांपल दिखा सकते हैं?
Please write down the examples. Okay, next heading is this. Vapor density and degree of dissociation. So we will take one example of this reaction where we have one species undergoing dissociation to form two different species. So A is dissociating to form B and C. All these are gaseous. So A is dissociating to give B and C. This is the example that we have taken in order to understand degree of dissociation and vapor density. Let's see how they are related. Okay, so first thing is the use of different notations. So let's understand the notations one by one. Initial vapor density is equal to vapor density of A, which is denoted by capital D. This means that when I have started the reaction, I have taken only A inside the closed vessel. B and C are not present initially. So A is present initially. So initial vapor density is denoted by capital D. And after equilibrium is established, the vapor density is called final vapor density. And it is denoted by small d. So understand the notations first. Initial vapor density is capital D, final vapor density at equilibrium is small d. Now, please keep writing. It's a derivation that we are doing here. So you have to understand the derivation. Now see, Vd is what? Short form of vapor density. Now I'm asking a question. Answer that question after looking at all these things. The question is, if I have this particular process, I mean, if I have this reaction, is this similar to what we have written?
So delta Ng is same.
Exactly, correct. So what that means, what I'm trying to say is, we are considering a dissociation process. A dissociation process is nothing but a reaction where one particular reactant will undergo a decomposition. That means on the left hand side, you must have one species. On the right hand side, you may have two different species or three different species, or you may have something like this where 2 moles of species are found. 2 moles of the same species are found. So this is also dissociation. This is also dissociation. This will also be dissociation. So understand the meaning of dissociation. Okay. You have to understand the meaning of dissociation first. So all these are examples of dissociation. Okay. Now see, if I write this, what about this? What about this? A giving B plus C plus D.
Sir, it is also dissociation.
Dissociation ही होना.
हाँ, it is also a dissociation. Right. It is also a dissociation. ये क्या हो रहा है, क्या कर रहा है, ये कौन कर रहा है ये? Who is controlling the screen?
Sir, annotations are off, so no one can access.
Annotation is off, right? Then who is doing it? Because वहाँ पे it is clearly visible, right? It is visible exactly कि क्या हो रहा है. Somebody texted me PC hang हो गया. नहीं, PC hang नहीं हुआ. Hang तो नहीं हुआ.
Sir, actually, you are sharing the screen, so we can't erase the matter that's written on your screen.
क्या?
Sir, आप screen share कर रहे हो ना, तो I don't think anybody can erase what's written on the screen.
Then how is it happening?
Yes, sir.
Like we can annotate, we can write if the options available. Like we can write on the screen that's being shared, but we can't erase the matter that's already been written on it.
तो फिर कैसे हुआ? क्योंकि
सर स्टाइलस या
Sir,
फिर माउस ग्लिच
glitch हो
होगा.
रहा होगा आपका.
सर आपसे
सर, वो
कुछ
कुछ तो
गलती से
लॉक
हुआ
और
रहेगा.
अनलॉक का ये भी आ रहा था.
किसका आ रहा था?
वो कैप्स लॉक का था सर. का
हाँ सर, कैप्स लॉक का ऑन और ऑफ हो रहा था कंटिन्यूअसली.
हाँ, ओके.
सर उससे नहीं हुआ रहेगा. आई गेस आपका स्टाइलस का कुछ इशू.
नहीं. Because I could see कि मैंने स्टाइलस नहीं हिलाया तो भी हो रहा था ना. Wait, let me see what is happening. क्या हुआ है वो तो I don't know. Let me start it again.
सर आप पार्टिसिपेंट्स चेक कर लीजिए.
Let me start that document. I mean, let me close that document and then start it. Meanwhile, you all keep revising the formulae done last time. Because we will be doing sums. आज के लिए theory हो गया, अभी sums करेंगे. Okay, so vapor density, which was initially present is called capital D. And final vapor density is nothing but the vapor density at equilibrium, which is called small d. I mean, it's denoted by small d. In the exam, sometimes you may come across capital D and small d. That is why I'm telling you this. It is not a hard and fast rule that you will have to use these notations, but then in the exam, sometimes they use capital D and small d. Whenever they use capital D and small d in a sum based on equilibrium, you will understand that they're talking about the vapor densities. Kindly don't feel that they are talking about the normal density. They are not talking about that. This density is different. This is what? Mass upon volume. So this is the density. This is just simply density. But if I say vapor density, that is capital D and small d. Okay. Now, degree of dissociation of A is alpha. So this is the notation for degree of dissociation. It is alpha. What is degree of dissociation? I have told you last time. Degree of dissociation is what? What is the formula? Check your notes. What is the formula for degree of dissociation? What is degree of dissociation? Alpha is the notation. How do you define degree of dissociation? It's a ratio. So what is there in the numerator?
Reacted moles.
Yeah, moles reacted upon,
Initial moles.
yes. This is the formula for degree of dissociation. Now, alpha is the notation. Okay, coming to vapor density. What is this? Capital D, small d. What is capital D? Half of molecular weight of A. Why A? Because initially only A was present. At equilibrium, we have a mixture of A, B, and C. That is why we'll say that at equilibrium, the vapor density is half of molecular weight of the mixture. The mixture comprises of A, B, as well as C. So vapor density is half of molecular weight. That is what we have to use. mass of the entire mixture at equilibrium. I'm talking about the mass, that is grams. Mass of the entire mixture at equilibrium will be same as the mass taken initially only of A. Mass cannot change because mass is conserved. That is law of conservation of mass. Law of conservation of mass. Mass is conserved. Tell me what else is same in this process. I mean, in any question of chemical equilibrium, what else is constant?
Temperature.
Okay, temperature is constant. What else is constant?
The closed container, no.
Ha, exactly.
So volume.
Any question where we are dealing with equilibrium is taking place in a closed vessel or a closed container. If it is taking place inside a closed vessel or a closed container, then what will happen?
Gas can't escape.
Yes, so what is constant? The volume is constant. Since the volume is constant, what else is constant? Tell me that now.
Pressure.
How will pressure be constant?
Temperature.
तो टेम्परेचर और वॉल्यूम ही रहेगा ना.
Temperature is constant, volume is constant. What else is constant?
मास.
वो तो मैंने बोल दिया पहले. Mass is constant in any chemical reaction. Law of conservation of mass. वही होता है ना. और क्या है फिर? What else is constant in this case? No. Somebody said moles. Never say this.
मोल्स नहीं रहेगा, डेल्टा एनजी है ना.
Never say this. Moles don't get conserved because in a chemical reaction, moles will change. Any chemical reaction is accompanied by a change in number of moles, but change in mass is not possible. Why? Because total grams will remain the same, but moles don't remain the same. Moles change. Any doubt? So what else is constant?
The equilibrium constant. Okay.
Yeah, that is okay. Okay, I'll frame it in a different manner. Mass and volume are constant. So what is constant?
Density.
Density.
Exactly. So it's density. Why is density constant? Because mass and volume both are constant. So density is constant. How do you find out density of a gas considering everything to be ideal? Use your gas laws.
PM by RT.
PM by RT, correct. What is M in that case? I mean, in that formula, what is M?
Molar mass of the mixture.
Molar mass of the gas if it is one gas, or molar mass of the mixture if it is a gaseous solution. So it's molar mass in short. Fine, okay. What is P there?
Pressure.
Pressure, okay. That is pressure.
The screen is not visible.
Yeah, I clicked on it just to see something that is not great. So now, if I want to calculate or to use the formula of density, what will I do? P1 Pm by RT, right? So what should I do if I want to find out the value of initial density of the system? I mean of A. How should I
सर
go
तो
ahead?
m को 2D लिखेंगे.
हाँ, that is okay. M को 2 भी लिखेंगे. That was not my actual question. मतलब मेरा ये intention था कि when you are using this, तो ये क्या होगा? That actually I meant this. M तो ठीक है, मोलर मास है. किसका मोलर मास है? Initially A का मोलर मास रहेगा. क्यों? Because only A is present.
So pressure inside
सर
the vessel.
nRT by V को.
No, that is okay, not that way. What is this pressure signifying? Can I say this is the pressure initially, that is initially when the reaction just started, that is P1, can I say?
Yes sir.
Sir, vessel तो closed होना चाहिए.
It is nothing but, can I say this? Correct? Where Na
Yes,
is the number of moles of A. What about pressure at equilibrium? Total pressure at equilibrium, how do I write that?
sum of partial pressures of A and B and C.
Sum of partial pressures of A, B and C, because all three are present. Okay, very good. So in other words, how to write that? I can write it in this way: PA plus PB plus PC. All these are at equilibrium. That's why I'm saying that all are present. And also, can I write in this way? N total. In this way, can I write?
Yes sir.
Yes.
Because N total will be Na plus NB plus NC. So if you put PA as NART by V, PB as NBRT by V, and PC as NCRT by V, then only we will get this. Because volume is constant, it is a container which is closed, temperature is constant, R is a constant.
सर ये डाल्टन्स लॉ ऑफ पार्शियल प्रेशर है क्या?
Ha, exactly. So inside the closed vessel, I am using Dalton's law of partial pressures. Because the volume and temperature both remain constant, I can directly say, now from what I wrote just a few seconds back, can I say this? Therefore, P1 by P2 is nothing but this. Can I say this?
Yes, sir.
Yes.
What I'm trying to say is that in any question of equilibrium, this holds true because volume and temperature are constant. Means initial pressure upon final pressure for the same reaction will always be equal to ratio of initial moles and final moles. So this is pressure at T equal to 0. This is the total pressure at T equal to T, that is at equilibrium. This is the number of moles of the reactant taken initially, if only one reactant was present. And this is the total number of moles of all reactants as well as products present at equilibrium. So this will come because volume is constant and temperature is also constant. So remember that this is always holding true for any question of chemical equilibrium. Any doubt? So we will assume all gases to be ideal gases. That is why we arrive at this relation. Now let's go ahead. So notations are clear,
एक मिनट
right?
वो वापस दिखा सकते हैं P1 by P2 वाला.
कौन सा? हाँ, this one ना?
नहीं सर वो जो रिलेशन हमने निकाला
हाँ वो I'll show, वो बाद में है नीचे, मैं पहले ऐसे ही
अच्छा
बता
वो
दिया
डिग्री ऑफ डिसोसिएशन का फॉर्मूला
है, सब है नीचे. Let's go ahead. ओके, नोटेशंस पहले लिख लो नोटबुक में, ये सब नोटेशंस के बिना आप बाद में कंफ्यूज हो जाओ.
सर वेपर डेंसिटी का एक फॉर्मूला और था ना, मोलर मास बाय 2 वाला, वो एप्लीकेबल होगा यहाँ?
वही तो किया ना मैंने, हाफ ऑफ मोलर मास. देखो यही तो लिखा है यहाँ.
ओके हाँ सर.
Vapor density is always half of molecular weight. Vapor density is half of molecular weight. Fine. That means capital D is the initial vapor density and small d is the vapor density at equilibrium. Mass of the system remains constant as per law of conservation of mass. Volume is constant because the vessel is closed. Mass is constant, volume is constant, density will be constant. Okay. Now use notation rho 1 and rho 2 for density, because D already we have used, so in order to avoid confusion. Right. So mass upon volume is equal to density, which is nothing but rho. Rho 1 is equal to rho 2 because mass by volume is constant. What is rho 1? Density at T equal to 0. And what is rho 2? Density at equilibrium. Density of the mixture. If nothing is mentioned, it is understood that we are talking about the density of the mixture, because we have a mixture at equilibrium. That is, all components are present, A, B as well as C. So let's take this. Again, we are back to the reaction. Now let us start the moles. If we start with 1 mole of A, then we will have 1 minus x moles of A left at equilibrium, x moles of B formed, and x moles of C formed. This means that x moles of A have undergone dissociation, because minus n के बाद जो होता है, that is called moles reacted or moles dissociated. Correct? Any doubt? Alpha. This is the formula for alpha. Moles of A reacted upon initial moles of A. So whenever we talk about alpha, this is the formula for alpha. Degree of dissociation is alpha. In this case, that is equal to x upon 1, that is x. Molar mass of A is Ma, because only A was present at T equal to 0. So molar mass of system is Ma at T equal to 0. That is initially when only A was present. Molar mass of the mixture is nothing but because of the gaseous mixture which is present at T equal to T. That needs to be calculated. So molar mass at equilibrium is M mix, which means M mixture. This is the way to calculate the molar mass of a gaseous mixture. That is total grams in the numerator upon total moles, which is in the denominator. So what is total grams? Total grams will be grams of A plus grams of B plus grams of C. And total moles will be again moles of A plus moles of B plus moles of C. If I look at moles of A plus moles of B plus moles of C at T equal to T, I can clearly add up the values. So 1 minus x plus x will give me 1 plus x. So the total number of moles at equilibrium is 1 plus x. This is the molar mass at equilibrium, which is mx. Any doubt? On solving further, if I open the bracket, I'll get this. So this is the molar mass of the mixture at equilibrium. And initial molar mass was what? Ma, because only A was present. Let P1 be the pressure at T equal to 0. That is only when A was present. And P2 is the pressure at equilibrium when we have mixture of A, B, and C. P2 is the pressure at equilibrium. Now we can use this relation. Pressure is directly proportional to number of moles because volume and temperature are constant. So P1 upon P2 is equal to 1 upon 1 plus x. What is this 1? Moles at T equal to 0. and this is moles at equilibrium. That is moles at T equal to T. So ratio of pressures will be equal to the ratio of moles because volume and temperature are constant. So I can write P1 upon P2 is equal to 1 by 1 plus x. And we know that density is same, so density remains constant. And hence we can put the formula of density. Pm by RT is the formula of density of an ideal gas. P1 is the initial pressure, P2 is the pressure at equilibrium. So I'll obtain this, R and T will get cancelled. Density is equal because mass remains constant and volume is also fixed because the container is closed. Density is what? Mass by volume. Mass is constant in any chemical reaction because law of conservation of mass says that. Volume is constant because the volume of the vessel is fixed because the vessel is closed. So density remains same as density is mass by volume. So I'm rearranging this, I'll get this. So P1 upon P2 is equal to M mixed by MA. Also that is equal to 1 by 1 plus x. Why? Because here we said P1 upon P2 is equal to 1 upon 1 plus x. So this is the relation that we'll get. So 1 by 1 plus x is equal to M mix by MA. What is M mix? I have already found out the value of M mix here. This thing is M mix. Put the value of M mix in this equation. So if M mix is substituted, and on solving I'll get this. MA is equal to MB plus MC. So they can ask you which of the following relations is correct for a reaction of this kind where A is giving B and C. So we can say that MA is equal to MB plus MC, where MA is the molar mass of A, MB is the molar mass of B, MC is the molar mass of C. Now coming to vapor densities. Vapor density is nothing but half of molar mass. So initial vapor density upon final vapor density will be equal to initial molar mass upon final molar mass. And already we know that from here mx upon ma is 1 by 1 plus x. Therefore, ma upon mx will be 1 plus x. So for this particular reaction, I can say that d upon d is equal to 1 plus x. Or alpha in terms of in place of x, because x is equal to alpha in this case.
So, तो आया कैसे equation d by d वाला?
Means I'm taking vapor density initial as capital D and final vapor density as small d. ये देखो ये वाला, ये डाल दोगे तो आ जाएगा ना. हाफ कट जाएगा. That is why it is like that. Now, in general, ये तो मैंने ऐसा रिएक्शन लिया था जहाँ पे A is giving B plus C, तो ये आपको रिलेशन आया. In general, ये आएगा. So we took a particular case, that is A giving B and C.
So n मतलब total
now what is n?
delta n है.
What is n? नहीं, delta n नहीं है. N is this sum of coefficients of products in reaction. N is sum of coefficients of products only in the reaction. Okay, someone has a doubt. That is 1 upon 1 plus x. कैसे आया? Okay. See, pressure initially is P1 and final pressure is P2. What is P1? P1 is the pressure at T equal to 0. That is only when A was present. What is P2? P2 is the pressure at equilibrium when A, B as well as C are present. If I look at this reaction, for T equal to 0, I can write P1 is moles of A RT upon V. I can write here P2 is equal to total moles RT upon V. And what is total moles? NT. Total moles is sum of moles of all species. So sum of moles means what? moles of C plus moles of B plus moles of A. If I add up 1 minus X plus X plus X, I'll get 1 plus X. So total number of moles is 1 plus X at equilibrium. Now divide P1 and P2. P1 upon P2 कर दो. तो RT by V कट जाएंगे. So you will be left with Na upon Nt. So P1 upon P2 will be equal to this. What is Na moles of A initially? How many moles of A were taken at T equal to 0? 1 mole. Nt is how many? 1 minus X plus X plus X. That is 1 plus X. So P1 upon P2 is equal to 1 plus X. Total moles is nothing but sum of moles of all species. I have 1 minus X moles of A, I have X moles of B, and I have X moles of C at equilibrium. So I added up all to get the total moles. Any doubt? Okay. So this is the generalized expression. Okay, now certain important terms. Theoretical vapor density is also called calculated vapor density, which is nothing but half of molar mass of only the reactant. That is the initial vapor density. And final vapor density at equilibrium is called observed or experimental vapor density. Final vapor density is called observed or experimental vapor density. Be thorough with these terms. What is Ma called? Capital Ma. It's called normal or expected molar mass. It is called normal or expected molar mass. Then what should mx be called? It will be called abnormal or actual molar mass. Copy the question and start solving. How will we start?
Reaction.
Yes. Then I said this is how we have to start.
Yes, sir.
Now see, in the question they've clearly mentioned that 100 grams of N2O4 were taken. 100 grams of N2O4 were taken initially, which means that when I started the reaction, I just had N2O4 with me inside the vessel. There was no other species present inside the vessel. I had 100 grams of N2O4. So I wrote 0 under NO2 because NO2 was not present. कहने का मतलब ये है कि क्वेश्चन में अगर कभी भी ये वर्ड दिखे या फिर ये वर्ड दिखे या फिर ये वर्ड दिखे, तो कोई भी ऐसे रिवर्सिबल रिएक्शन के क्वेश्चन में अगर इन तीनों में से कोई वर्ड्स दिखे, इन तीनों में से कोई भी एक वर्ड दिखा क्वेश्चन के अंदर, दैट मीन्स सिर्फ और सिर्फ वही चीज रिएक्टेंट के साइड पे प्रेजेंट है। तो रिएक्टेंट साइड पे सिर्फ वही चीज प्रेजेंट है। कौन सी चीज? वो चीज जो टेकन है या प्लेस्ड है या हीटेड है रिवर्सिबल रिएक्शन के अंदर। तो ये आप याद रखो। So whenever you see
Out
these
है।
words, you have to
Sir?
immediately take that thing to be the reactant.
सर क्वेश्चन में बोला कि वेपर डेंसिटी 38.3
हाँ
है।
सर, तो फिर मोलर मास डायरेक्टली नहीं निकाल सकते।
हाँ
हाँ।
सर 92 बाई
निकाल सकते हैं ना, वही तो मैं बोल रहा हूँ। तो ये क्वेश्चन में क्या क्या बोल रहा है, लेट्स अंडरस्टैंड। पहले मैं ये वर्ड बोल रहा हूँ कि जो टेकन और प्लेस्ड और हीटेड वर्ड है उस पर फोकस करना है।
नहीं सर, मैं ये बोल सर, आपने 92 लिखा है ना सर, उधर 100 के।
हाँ 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 92 करेक्ट। सो ये हो गया फाइन। हीटेड, टेकन, प्लेस्ड, इन तीनों में से कुछ भी हुआ तो क्या करना है, वो चीज रिएक्टेंट साइड पे होनी चाहिए। दैट इज द फर्स्ट थिंग टू बी टेकन केयर ऑफ। सेकंड थिंग टू बी टेकन केयर ऑफ इज दिस वेपर डेंसिटी। क्वेश्चन में अगर कभी बोलते हैं वेपर डेंसिटी ऑफ सम सब्सटेंस इज फाउंड टू बी सो एंड सो, इज ऑब्जर्व्ड टू बी सो एंड सो, और इज सो एंड सो, बाय डिफॉल्ट इट इज अंडरस्टूड कि क्वेश्चन में अगर वेपर डेंसिटी देके रखा है, क्वेश्चन में जो वेपर डेंसिटी देके रखा है, that is always going to be the observed value of vapor density. I repeat, क्वेश्चन में अगर वेपर डेंसिटी किसी चीज का देखे रखा है और आपको पता है कि रिवर्सिबल रिएक्शन है, तो that is by default the observed value of vapor density. What is observed value of vapor density? नोट यहाँ पे है आपको टर्मिनोलॉजी। Observed vapor density is experimental vapor density, which is nothing but half of mx, or I can say it is equal to small d as per the notation. तो क्वेश्चन में जो भी वैल्यू देके रखेंगे वेपर डेंसिटी का, that is experimental or the observed value of vapor density, which is small d. So 38.3 is the value of small d. और हाँ, हमें ग्राम्स में काम नहीं करना है, हमें मोल्स में काम करना है। इसके लिए 100 ग्राम्स को मैंने मोल्स में कन्वर्ट कर दिया। Now initial vapor density क्या है? कैपिटल T है। How will you find out that? That is half of molar mass. मोलर मास किसका? सिर्फ और सिर्फ A का, यानी रिएक्टेंट का। कौन हमारा रिएक्टेंट है? N2O4 हमारा रिएक्टेंट है। तो N2O4 का मोलर मास कितना होता है? 92 होता है। उसका हाफ करूंगा तो 46 आएगा। So 46 is the initial value of vapor density. What is the final value of vapor density that is given in the question? 38.3. So now we know initial and final vapor densities. We can apply the formula. Initial upon final is equal to 1 plus n minus 1 into alpha, where alpha is the degree of dissociation. And n is the sum of coefficients of the products, which are my products here. I have only one product here, that is NO2. The coefficient of NO2 is 2, so the value of n is 2. This is the substitution. From here, I can get the value of alpha.
सर हम अल्फा को x के टर्म्स में लिख के सीधा x की वैल्यू भी निकाल सकते हैं.
हाँ, कर सकते हैं. अल्टीमेटली तो करना ही है. बट अल्फा पूछा था डायरेक्टली क्वेश्चन में ना, फाइंड आउट द वैल्यू ऑफ डिसोसिएशन, परसेंटेज डिसोसिएशन, ऐसा पूछा था उन्होंने. पहले अल्फा निकालो फिर एक्स निकालो. अल्फा इज कॉल्ड डिग्री ऑफ डिसोसिएशन. And percentage dissociation is called 100 into alpha.
सर एक डाउट है. सर अगर कोई किसी चीज का परसेंटेज डिसोसिएशन ढूंढना हो और मतलब हमें डिग्री मिल गया, तो सर वो मतलब ज्यादा डेसिमल प्लेस तक निकालना पड़ेगा, क्योंकि परसेंटेज में भी 2 होना चाहिए.
हाँ हाँ, सेकंड प्लेस तक निकालना चाहिए. सेकंड प्लेस ऑफ डेसिमल.
परसेंटेज में भी हमें 2 तक निकाल के राउंड अप करना, तो इनिशियली तो हमें 4-5 भी निकालना पड़ेगा.
हाँ हाँ हाँ, करेक्ट करेक्ट, दैट इज दैट. बट ये तभी करना है अगर न्यूमेरिकल टाइप क्वेश्चन आया जेईई मेन में तभी. अगर ऑप्शंस में है तो ऑप्शंस को देख के नियरेस्ट ऑप्शन चुन सकते हैं. न्यूमेरिकल टाइप आ गया तो फिर करना पड़ेगा सॉल्व ज्यादा. So percentage dissociation of N2O4 has been found out. Percentage So this is the final answer for percentage dissociation. Now what is alpha? Moles reacted. How many moles are reacted? X moles are reacted. And how many moles are present initially? 100 upon 92. So X upon 100 upon 92 is called alpha. So alpha is what? Degree of dissociation, that is moles reacted upon initial moles. X moles have reacted initially, 100 by 92 moles were present. Alpha we have found out 0.201. Put the value. From here I will get the value of X. क्वेश्चन में पूछा था फाइंड आउट मोल्स ऑफ NO2 at equilibrium. कितने हैं moles of NO2? If we go back to the this reaction, we have 2x moles of NO2 present at equilibrium. ये है moles of NO2 at equilibrium. So 2x is the moles of NO2 at equilibrium. So this will be the final answer.
सर थोड़ा ऊपर स्क्रॉल. हाँ सर.
Next question. Copy the question. क्वेश्चन में रिएक्शन देके रखा है. Okay, now see, in this question they have clearly mentioned that Cl2O7 is placed. Placed means what? That should be the reactant. And I am supposed to find out degree of dissociation of Cl2O7. But in this question, nothing is mentioned about vapor density. If nothing is mentioned about vapor density, do not use the formula for vapor density. So ignore vapor density because nothing is mentioned about the vapor density here. Now, initial pressure is mentioned, final pressure is mentioned. What is initial pressure? Initial pressure is 500 mmHg. 500 millimeter mercury is the initial pressure. That means that will be the pressure only when the reactant was present. At equilibrium, the pressure is 750 millimeter mercury. That means the pressure of 750 millimeter mercury is because of the partial pressures of all the components present. So the pressure at equilibrium is nothing but equal to the sum of partial pressures of all the reactants and products. That means 750 millimeter mercury is the total pressure at equilibrium. So now I can start the reaction in this way because I have been given the reaction in the question. I can write the reaction and then start working in terms of pressures. Initially, when I started the reaction, I had Cl2O7 with me in the vessel. And so I wrote P naught mmHg is the unit of pressure mentioned. So let's take everything in mmHg. So here also everything will be in mmHg. Yes. Wait.
Sir, whenever we get these types of questions, will we be given the reaction itself?
रिएक्शन दिया रहेगा लेकिन जो 10 रिएक्शंस पहले लेक्चर में मैंने दिए थे उनमें से अगर होगा तो नहीं दिया रहेगा।
ओके सर, अभी रेशियोज लेना इसलिए हम लोग को एसआई यूनिट में लेने की जरूरत नहीं है ना?
हाँ एग्जैक्टली, एसआई यूनिट्स में लेने की जरूरत नहीं इस चैप्टर में। एसआई यूनिट्स हम लोग यूज करते हैं सिर्फ थर्मोडायनामिक्स में क्योंकि वहां पे जूल्स में काम करता है इसके लिए। Now, initially I had P naught mmHg and that value of P naught mmHg is given as 500. Initial pressure was 500. That means P naught is 500. After some time, equilibrium is established. So I can write in this manner, that is at T equal to T. I am left with P naught minus P mmHg of Cl2O7, which means that small p indicates how much of Cl2O7 has been reacted. So small p mmHg of Cl2O7 has dissociated. And because small p mmHg has dissociated, I should get 2p mmHg of ClO2. Why? Because if I compare this coefficient and this coefficient, then the coefficient of ClO2 is 2 times the coefficient of Cl2O7. Therefore, this and this also should be in the same corresponding ratio. So 2p is 2 times p. Similarly, this 3 is the coefficient of O2 and 2 is the coefficient of Cl2O7. So 2:3 is the ratio. So this small p and this should also be the ratio of 2:3. It is mentioned that P naught is 500 mmHg. Also, it is mentioned that at equilibrium the pressure is 750 mmHg. That means the total pressure is equal to 750 mmHg at equilibrium. So PT, that is pressure at time t, is equal to partial pressure of Cl2O7 plus partial pressure of ClO2 plus partial pressure of O2. So I've added up the partial pressures of Cl2O7, ClO2 and O2. That is equal to 750 as per the question. So pressure at equilibrium is 750. On solving this, I'll get small p as 100.
सर आपने डायरेक्टली इसमें प्रेशर लिया क्योंकि मोल्स कांस्टेंट मतलब डायरेक्टली मोल से इक्वल है ना कौन मतलब
प्रोपोर्शनल है, हाँ, प्रेशर इज प्रोपोर्शनल टू मोल्स। और यहाँ पे क्वेश्चन में प्रेशर के टर्म्स में ही इंफॉर्मेशन देके रखा है, इसके लिए मैंने प्रेशर यूज किया है।
हाँ ठीक है।
क्वेश्चन में अगर ग्राम्स देंगे तो आपको मोल्स में करना पड़ेगा।
तो अल्फा को पी नॉट मतलब पी बाय पी नॉट लिख सकते हैं।
हाँ, एग्जैक्टली। The partial pressure of ClO2 is how much? 2p mmHg. क्वेश्चन में वही पूछा था ना, find out partial pressure of ClO2. Partial pressure of ClO2 is how much? 2p at equilibrium. So 2p, p का वैल्यू आ गया, 2p आ जाएगा फिर। Now coming to degree of dissociation. बोला है find the degree of dissociation. Look at the reaction here. So degree of dissociation will be what? Partial pressure decomposed upon initial partial pressure. So P upon P naught. So P upon P naught is alpha, which is degree of dissociation. Small p we found out 100. Capital P naught is given in the question is 500. So 100 upon 500 is alpha, which is 0.2. Percentage dissociation was not asked for, so let's not calculate it. Alpha is called degree of dissociation. If percentage dissociation is not asked, don't calculate percentage dissociation. Calculate only degree of dissociation. If they ask you for degree of dissociation only. Okay, so the next one. NH4HS is placed inside a closed container. NH4HS is heated inside a closed container. The pressure at equilibrium is known to us. Find Kp. So what is the first task? The first task is to write down the reaction. I have given you the reaction, so we can use that. This is the reaction. So initially this was not present. Now the total pressure at equilibrium is given. The total pressure at equilibrium is given in the question. If you look at NH4HS, that's a solid, so that will be ignored completely. So let's say that here I have P ATM, then here also I will have P ATM, because 1 and 1 coefficients are same. So P ATM and P ATM are the partial pressures of NH3 and H2S respectively. Total pressure is 1.12 atm. So I can say total pressure is nothing but partial pressure of NH3 plus partial pressure of H2S. So P atm plus P atm. I'll get the value of P. Now Kp, question has asked us to calculate the value of Kp. Kp will be partial pressure of NH3 to the power of 1 into partial pressure of H2S to the power of 1. Because 1 is the stoichiometric coefficient of each of these. So Kp will be equal to this to the power of 1 upon the reactant. But reactant is a solid, so I have to ignore the solid. So this is going to be the expression for Kp. I will not take into consideration the solid, and hence I cannot write upon P of NH4HS. I cannot write this because it's a solid. So ignore the solid completely. This is Kp. So 0.56. So 0.56 square, that is 0.3136. Also, if I want to mention the units, ATM square. So ATM into ATM is ATM square. Any doubt anybody has? Okay. So 0.3136 ATM square is the value of Kp. So this is a reaction.